Okay, welcome back. So in this video, I'm going to load up a fiber data set. And in this case, I want to demonstrate a few things, including some more segmentation tools and some shape tools. And then following on that important topic of watershed segmentation, which is something very useful when you're trying to separate objects such as touching fibers. All right, so let's see if we can get through all of that. I actually had a failed effort just a few minutes ago, partly due to interruption here while I was recording. So I'll just start a new session just to start up from scratch. Right, so we're going to, in this case, import an object. And it's a fiber data set, which I don't actually know much about this data, except that it's a whole bunch of fibers, probably glass fibers within some matrix. What we can do is we can just view that and just show that briefly in 3D. And if we change that to a, let's take this one. That's not very nice. Take a preset like that. So you can see what the fibers are looking like, and they have different orientations, which we will also get to later. For now, all I want to do is make a segmentation and show you some segmentation tools, which I've not shown already. So the first tool I want to show, as you know, the define range tool already. In this case, it's showing an upper Otsu on the material with the air around it, and then there's some pixels outside. Just to show you that and refresh your memory, if we go to the main tab, is a probe tool. So we can use the probe tool to look at that. For example, if I click there, I see that the outside pixels there have a value of 1, and these pixels here have a value also. Oh, these pixels have a value of 25,000, and the fibers have 37,000. So because there's multiple phases here, it's a cropped data set with 0, basically pixels with value of 1 on the outside. This is messing with the Otsu, so we can manually change that. You can change that like that. You can also calculate your own values, set your threshold here, 35,000, for example. This is a 16-bit data set, so it's going to 65,535. You can also just select upper Otsu like that, like we had done before, add to a new, and then use the split that Otsu of that particular region of interest, which I've shown you also before. So in that case, we have fibers and background. So we can delete those two. I've highlighted both, and we can delete those two. We now have fiber segmented. The red is still a preview of the define range. Now, at the moment, we have all these fibers and this exterior there. So let's show you how to remove these, this bit of exterior, which we don't want. If we use an opening function, which is a combination of erode dilate, that removes that quite nicely without changing anything else. So that's quite widely used, and in this case, it's quite useful. But we still have some touching fibers all over the place, as you will see there. So you can toggle between this. We can change the brightness here just to show you that. And if we look at you can also change the opacity of this region of interest over here. It's got a highlight. You can make it less bright or more bright. Okay, but the point is really, that's one way to segment, but they are still touching, which is why we will get to if we want to analyze each fiber separately, we need to separate them somehow. So that's what we will use the watershed for. before we get to the watershed, I want to demonstrate some more segmentation tools. So let's say we are interested in segmenting one fiber and following one fiber like this one, for example. One way of doing it is to manually paint it. So we can go to a single slice tool and paint using, we can create a new region of interest, an empty one called single fiber. And we can make it yellow to stand out from the rest. And to be, there's nothing to view yet. There's nothing yellow yet because no pixels are painted yet. If we go to this 2D brush tool, we can use the default is the full paint tool. So this is a round or a square painting brush. And if we're painting like this, we can paint any pixels we like only in this slice. If we scroll through it, we see it's only there. This is with the control button and the left mouse button. To remove some painted material, you take the shift button and keep it pressed and scroll and move your mouse over that. So now, if you're wanting to paint quite fast, you might want to use the define range, which we can just put the green off now for now. We want to use, if we want to select the fibers like that, but we don't want all, we want to paint only there. If we now are using the full brush, but it's, so we're using the painting tool, but it's being limited by the range selection. So that's a nice way to paint a fiber like that. And you can make your brush bigger and smaller by scrolling the mouse wheel. And then you can quite easily paint slice by slice like that without doing much effort on the edge of it. So the next thing which is I want to demonstrate here is the, let's just put this define range off. You need to remember to put that off. If we want to continue this, we might want to go to, I wanted to show the single Otsu brush. So it was painting full. So if I do that, it's painting everything, right? So also there's an undo button for one step. It's only working for one step back. So let's do a local Otsu brush. This is very useful. You can use lower or upper Otsu brush. The lower brush takes all the pixels in the area of this circle and takes all the lower pixels and paints that. That's not what we want. So we can go to the undo button again, and we can go to the upper Otsu brush. So for that, we want to paint very nicely, and that's working quite nicely there. Also works all over the place like that. It works quite nicely. You need to have within the area of the paintbrush both materials that you want to separate. So if you're having the brush there, it's not working. And if you're having the brush only there, it's not working so well. And you can make your brush quite big and remove things like that. These are the basic painting tools. There's also, let's take, for example, let's say we want to see, this is quite useful to see all pixels that are all voxels which are connected to this fiber location here. We can use this, which is a point and click tool. It's like a region grower tool. So you take the green region of interest, because that's what we're interested in, and we point and click there, and now it's showing us, oh, it's only working in 2D, of course. We can do that over multiple slices, over 3D. And now it's connecting everything that's connected to that particular fiber. So it's not that many. It seems to be about 3 or 4 fibers that are connected there to each other. You can do the same thing there. And the same thing there. That one's not touching many things. So that one's actually separate from everything else. So that's quite nice. But okay, that's the point and click tool. So let's see what else that I want to show you here before we move on. I think in terms of, oh, there's one more thing I wanted to show you, and that is if you're using a define range to select, you can put the green off, to paint. So I hope the recording is okay. I just had a power outage here. Problems with South Africa. We have regular power outages. I have battery packs and no problems to work around it though. What I wanted to demonstrate here is, let me just see, yeah, it seems the recording is still continuing. Right, so what I wanted to show here is if we have a single, let's say we have some region painted. Let's take a full, we have a small bit of material painted here. If we now, actually, let's just clear everything. That's also something I didn't show yet. Just clear the entire region of interest. And now we can paint there. So now what we can do is we can take that and dilate it. And our dilation function is well known, but now it's actually following only up to the edge of that range selection. So in this way, you can, let me show you in 3D. Let me just find the exact location of that fiber. So in 3D, now we are dilating. You can see this fiber being filled up as we continue, because it's staying within the range and it's not actually touching anything else at the moment. So that's a nice function to know about, to use the define range works in combination with all the other tools, all the other segmentation tools. So that's when you want to segment a particular feature. I think I've segmented only one fiber. I'm quite surprised it's not touching anything, but we can check that out by viewing in 3D a single fiber, and it is actually a single fiber. So that's quite nice. Right, so that's all I wanted to do at that point. Let's go back to the data, and what I want to demonstrate further is a cylinder function unwrapping. Not the best data for that example, but this was part of the training, and I'm reproducing the training order and everything done during the training. So the software is really big and there's a lot that can be covered. So I hope I'm covering, we hope we've decided on doing the best coverage of the topics of interest. What I'm doing at the moment is I've created a cylinder shape. Shapes can be used for many different things. You can crop data, you can select certain regions inside or outside of the shape. But one thing that you can do is you can actually, let's just get the crosshairs across there so we can see where we're at. We can make it follow a particular fiber because the fibers are cylindrical in shape, and we can unroll that fiber. So by moving like this, we can follow an individual fiber. Let's see if I'm following the correct fiber here. It seems okay. It's not the best fiber in the world to be following. I think the angle is just needing to be adjusted here on this side. So sorry, let me just align this fiber. Too many things close to each other at the moment. Okay, so it's close to aligned there. Pretty close. So what we can do, we've got a cylinder now, and what we can do now is we can go to the main tab, Under scenes view properties, you can show a non-planar view. So this is now unrolling around the perimeter of the cylinder. So this is a way of visualizing some cylindrical feature, which is unwrapped like a soup can wrapper, which is flattened out. The same thing can be done with a sphere, and we can also change that location and geometry or diameter of that. All right, so it might be more useful to unroll a more complex object, but I just wanted to demonstrate that. It's also possible to unwrap more complex features. In a single plane view, you can make a complex geometry and then extrapolate that to 3D and unwrap that. All right, so the next thing to do to demonstrate here, I think I've already shown how to save screenshot. You can right click here and export screenshot of view and change the size to 4000, for example, and save that. You can also, on the main tab, there's a multiple screenshots panel. So you can take this screenshot. It's a bit difficult with the zoom controls here. Let me see. No, that's not the correct one. So let's just say that little camera button, you drag your image that you want, and you can take multiple images like that. So you drag and drop multiple images. As you are working, you might want to select 20 images and then at the end export all to a particular folder and give it all one name with a number 1 to 20, for example. So that's how to do that, to make multiple screenshots. I've already shown how to make a 2D animation, and we will later get to the 3D movie maker, not right here. So at the moment, the next step is to do the watershedding. So let's remove the cylinder and the single fiber. And at this point, I want to change back. Actually, it's quite easy just to refresh all views. And that's quite a nice view over there. You can actually view that in orthographic projection, which shows you that it's not actually, they're not all aligned vertically. We'll get to the alignment later, but for now, we want to do a watershed segmentation because this thresholding segmentation still had many features touching. So this is the basic, let's say the fibers thresholded. Okay. So now what we're going to do is we're going to demonstrate how to make a classic watershed. So for that, we need to make a seed in the middle of each fiber. The watershed algorithm works with seed points where water, it's like a landscape with hollows, and water, if there's a seed point, water will fill up in each seed point until it's touching another water boundary. And at that point, they separate it, even though they are touching. So let's demonstrate how to do that. There's different ways of doing it. I'm going to demonstrate the classical way. So what we need here is we need to take this threshold. Let's make a copy of it because, did I click on it? Okay, there we go. So because this copied version now, let's just keep the original one there. This copied version, I want to make an invert. So I want this background to be this. And the reason for that is we're going to select, right click on it and create a mapping of a distance map. So what this does is it creates a map of all points outside the region of interest, how far it is from a region of interest voxel. So it's making a distance map within the fiber, which is going to allow us to make seed points right in the middle of each fiber. So if we do that, if we view that distance map, you see that's what that looks like. We can also change the opacity of it, I think. If we go to Windows leveling, so if we change the opacity of it, we can see that both, we can change this to maybe something more, let's see, what can we change it to? So that makes it quite clear that we can make seed points like that. But let's keep it grayscale because it might confuse us a bit. Wait, not that one. Let's keep it a regular grayscale. Whoops, that was by accident. Okay, so we can change this contrast of this as well. Okay, so what we want to do is we want to segment based on that. So we want to make a new thing called fiber seeds and a new region of interest. So if we now define range based on the distance map, we want to use the upper Otsu because the distance map makes higher pixels in the middle, higher valued pixels in the middle. So for this, we just threshold manually until each fiber has at least a pixel or a couple of pixels in the middle, but they should not be touching anywhere. So you can check at this point that they are not touching, like those. This is still something which is not perfect. They are not touching, but should look around until they are not touching anywhere. So, okay, let's say that's fine. We're going to add that. So now we have fiber seeds and we can put this define range off. So now what we need is we've got a distance map. Let's put this distance map off. Oh, actually what we want to do is we want to take the distance map and invert it, because what we want is a landscape where the center of the fiber is the lowest value. So we go to modify and transform and invert. So we invert the values and we can create a new one. So now we have a distance map like that. And we have a fiber. Let's see if we can easily contrast this. So it's darker in the middle of the fibers, and that's the landscape that we're going to use for the watershed. So now we have a seed and this, and I think we can apply the first thing we need to do now is the seeds have to be a multi-region of interest. So we need to create a new multi-ROI, and we're going to use 26 connected because we don't want them at all to be connected. So if we have that, now each fiber has a separate color, each seed of a fiber has a separate class. So now we can right click and we can say watershed transform. So they'll choose a landscape. We want to use the distance map fibers. Let me just check. Let me just get the naming right. This is the landscape. Let's call it landscape. And on the multi-ROI, by the way, I don't think I've explained very carefully. A multi-ROI is like a region of interest, except each there's different classes that are set. Each item has a different class. So it's like multi ROIs. It's like multiple regions of interest. And this is very useful for selecting certain areas or certain items within a region of interest. So it's used for many functions and it's necessary for deep learning tools. So let's go to the watershed transform. We're going to be using the landscape. The mask is actually the original fiber thresholded because that's where the fibers are. We don't need to search outside of that. Let's see if this works. It should be quite fast. All right. So we can now go back to the original, we can put the landscape off, and we can show the fibers that are not, I mean, each fiber is separated. There's a good example over there. There's two fibers which were touching before, and at the moment they are separated. So that's quite nice. So now we have a 3D nice fiber separation using Watershed. So now each fiber in this multi-ROI has a separate class, and now you can apply some analysis to it, to these separated fibers. What you can also do to the multi-ROI is you can add and remove particular fiber regions. Like let's say this one, for example, if we look at its center of mass, if we right click and move to it, let's see, where is it? So this one, if we look at this one, look at center of mass, there's nothing wrong with that fiber. I don't want to remove it, but if you are interested to, for example, see this fiber more clearly, then you can drag the slider up to increase its visibility. Actually, all of them are quite bright at the moment. So you can just also switch it off entirely if you're not interested in it. So you can also remove, and you can add manually to this region of interest or multi-ROI. All right, so I think what I can demonstrate here, I'm just wondering if we can do the angular analysis. Let's do a scalar generator, apply. So I right clicked and chose scalar generator, and I'm going to do basic measurements of fibers by volume and phi and theta. These are angles. Right, so that's done. Now we can calculate by volume. So let's sort by volume, and we can have a look at the biggest one. There's nothing wrong with that. I was wondering if any are still connected, in which case the volume would be quite large. So everything seems fine. So this is sorted by volume. The volumes are, obviously there are different volumes because some are shorter than others, and the shortest ones are purple. These would be near the clipping of the data, near the edges more. So, and the longest one would be the one more diagonal, actually, in this case. But what we're interested in here is the angle. So let's look at phi, which is, there's two angles. One is along the z-axis and the other is around the z-axis. So that's the phi and that's the theta. So yes, the phi angle is along the z-axis, and you can see most vertical fibers. Let's just change the color. We can change the lookup table, right click on that and choose a temperature color map. So most vertical fibers are blue and most fibers horizontally are red, and in between is green. So that's a directional analysis, and you can click on this histogram to analyze that directional fiber orientation, and you can save that or export it to a CSV file. You can also change the number of bins and so on. Okay, so I think that's almost everything I wanted to do here. What I want, it's quite a nice demonstration, so I think I'm going to stop at that point and leave histographic segmentation for a next session. All right.